Okay. Hi, everyone. I'm Frank, technical leader from the China Tech team. Welcome to the new edition of the Wireless Technique to Know. And today, I'm very happy to share you with the topic of LAN switching basics. Okay. Moving to the agenda for today, I prepared two parts for today. In the first half, I'll be introducing the latest product line of the Cat9K switching to help you get familiar with them, and also introduce some of the common hardware and software features of the Cat9K switches. And in the second half, I'll spend some time to talk about some basic concepts in the switching, just like MAC address learnings and forwardings, VLANs, spanning tree, which you might have learned from your CCNA or CCNP courses. So personally, I feel that the second half actually might be relatively boring when you compare it with the first half. So my idea is I'm not gonna deep dive into any specific topic in the second half, but provide you the tips and the command lines which are useful for you in your future daily work. Okay. Uh, so let's get started from the Cat9K switching. Actually, a couple of years ago, when I present the same topic to my team, I can use the Cat9K only as my title. But today, what I need to do is to add the word switching right behind the Cat9K to clarify my topic. Actually, one of the reasons make me to have to do this is, as you already know, we have the brand new wireless products. I mean, the 9800 and 9100 join as a very important part of the Cat9K family. So I think from the company level, I'm pretty sure that BE and marketing team have a lot of reasons for this rebranding. But what I believe is one of the reasons support them to do this is the success of the Cat9K switches. Actually, like the fastest ramping product in the Cisco history and reaching to the 20 billion bookings with 4 million units shipping by the last year. So at this point, we should see that Catalyst is no longer a switching platform. It's now a new product line for the enterprise and especially for access network. In this access network portfolio, as you can see from the slide, we do have the Catalyst switches from the core switching and the access switching. And apart from that, we do have the wireless products along with the DNA center as a network controller, and S, which you may be familiar with, that is the identity and the policy services provider. And um, so today, of course, we are focused on the switching part. So moving to the next slide, I'll introduce the Cat9K switching portfolio. Let's take a look at this slide. Cat9K actually has a comprehensive product line which replace the entire legacy catalyst from 2K all the way to 6K. From the marketing perspective, the switches are divided into two categories. One is the access switching. You can see on the left side, contents of the 9200 series, 9300 series, 9400 series. And another part is the core switching, which contain only the 9500 series and the 9600 series. Okay, and at this point, we actually have a new generation of the Cat9K switches, which is named as the X series. As you can see from the top of the slide, the 9300X series, 9400X, 9500X, and 9600X are actually the products of the new generation. And one more thing I want to mention is about the hardware and software of the Cat9K switching platform. The Cat9K switches are powered by the Cisco ASICs, Most of them equipped with the Cisco UADP 2.0 or 3.0, and the latest ones, the 9500X and 9600X, are equipped with the very famous Silicon One ASIC, and the version ID is Q200. Talking about the software, regarding the software, Catalyst 9K switches are running on the Cisco iOS XE software. That's very similar with the 9800 in terms of the software architecture, release schema, and the features. So you may look back to Nico's presentation for more detail about Cisco iOS E. But today, the only thing I want to highlight here is 9K switches that may share the same software image among different products. For example, so one image that you are running on the Catalyst 9300 can be installed on the 9500 and 9600 as well. So for the customers on our sales, we don't need to download or maintain many files for different products in Cat 9K series. For each version or each rebuild, we only need one file, one image file for all Cat 9K switches. Yeah, but actually we have an exception. The only exception is the 9200 series. Because it's running on actually the light version of the iOS XE, because the limits of its RAM, actually 9200 has a smaller size RAM, so 9200 doesn't share the same file with the others. Okay, next one. Okay, then let's take a closer look of each product we have in Cat 9K. The first one and the best-selling one in Cat 9K is 9300. It's the access switch and it's the 1U fixed module, actually with modular uplink options. And for those with fixed uplinks, they are named as the 93L series. And of course, for the next generation, we have the 93X series, also with the modular uplinks. So basically, we have three series in the Catalyst 9300. The first one is the standard series, and another one is the X series, and the last one is the L series. Okay. I believe that most of you might have ever seen 93 stacks in either your lab or customer's environment. So basically, the stacking is supported to have up to 8 switches to form a stack. Each switch have 2 physical stack ports, and the switches should be connected like a ring. Once the switch are well connected and after the reload, the stack will act as one logical switch, and the active switch will take control of the control plane of the whole stack. Okay, and talking about the standby switch, the standby switch will monitor the health of the active switch and take over the active role when active switch is failed. The rest switch will be the member switches and might be elected as a standby upon the switchover. Okay, so depends on the different module of the 9300. The stacking ring backplane could support up to 1 terabit gigabit for the 9300X series stack, and 480 gigabit for the standard 9300 stack, and 200 gigabit for the 9300L series stack. Moving to next is also about the stacking. It's also possible that to group 9300 switches in different series in a stack. You can put, for example, you can put standard 9300 and the 9300X in one stack, but the backplane capacity will adapt to 480 gigabit. Actually, that's a maximum number that the standard 9300 can support. Okay. However, the L series 9300 switches, they are not capable to do the mixed stack with any other series switches. Okay, and one more thing is to form the stack, it is required that the switches in the stack should run the SIM-iOS version and the license. Otherwise, you may see some of the switches are not able to join the stack. That's all about the stack. And next one, let's come to the 9400. Basically, 9400 is the modular switch and very much like the 4500. Actually, it's the next generation of the 4500. Okay, it has the 4 slots, 7 slot, and 10 slot chassis, as you can see from this slide. Each of those chassis have 2 dedicated slots for the supervisors. Those cannot use for LAN cards. As you can see from the slides, the slot 2 and 4 for 4 slot chassis, slot 3 and 4 for 7 slot chassis, 7 4 to 6 7 5 slot 5 to 6 in the 10 slot chassis are only capable to install the supervisors, and the rest slots in the chassis are capable to install the forwarding LAN cards. Apart from that, the fan tree and the power supply are also changeable as well. At this point, 9400 have 4 types of the supervisors in 2 generations. The first generation consists of the Super 1 and the Super 1 XL. They are powered by the Cisco ASIC UADP 2.0 XL. And the second generation, which also called the X series, consists of the Super 2 and the Super 2 XL, which are equipped with the UADP 3.0 stack ASIC. Super 1 engine support up to 80 gigabit LAN rate forwarding per slot, and the second generation provide up to 480 gigabit capacity per slot. Take a look of the LAN card of 9400. Actually, the 9400 as a modular access switch. The 9400 LAN cards provide up to 10 gigabit connection to its endpoints, and most of the LAN cards can support the PoE function. With the support of the AO2.3BT, the LAN card provide up to 90 watts of the power onto the cable. The 9400 also provides the LAN cards with multi-gigabit ports. Regarding the M-Gig, we'll talk about in the coming slides. Moving to next is 9500. Is designed as a core switch. Is the 1U fixed module. And in terms of the forwarding ASIC, as you can see from here, actually there are 3 generations for the 9500. The first generation is the ones with the UADP 2.0 ASIC. They are provide ports in rates of the 10 gigabit or 40 gigabit rates. And the second generation is named as a 9500H. The letter H here is actually standing for high performance. So switches in this generation are equipped with the UADP 3.0 and provide ports up to 100 gigabit. The latest generation, the X series, as you know, powered by the Silicon One ASIC and could provide port in 100 gigabit or 400 gigabit rates. That's all about the 9500. Another core switch in the K9K portfolio is the 9600. It's designed as a replacement of the legend K6K, you know. And but at this point, the 9600 only have 1 chassis module with 6 slots. Similar with the 9400, there are 2 engine slots in the middle, and the LAN cards can be installed in any of the rest 4 slots. When comparing the 9600 with the 9400, 9600 provide ports in higher rates. For example, 9400 LAN cards provide ports in up to 10 gigabit rates. And however, the 9600 LAN card can support up to 100 gigabit or 400 gigabit, depends on the supervisor version. The supervisor tool is the latest version engine with the Silicon One ASIC and can support 3.2 terabit capacity, switching capacity per slot, which means in total, actually we have 4 forwarding LAN card slots in this chassis. So we have 4, if we have 4 forwarding LAN card, in total, the supervisor tool can provide the capacity of 12.8 terabit per second. One more thing I need to mention is that the 9600 as the core switch actually it's very rare to be connected to the PoE device like IP phone or access point. So as of now, none of the 9600 LAN card support PoE function. Moving on to the 9200. Actually, 9200 is the low-end access switch in the Cat 9K portfolio, and the 9200 have basically two series. The first one is 9200 with modular uplinks and fans, and another one is the 9200L, which only provides a fixed uplink and fans. And apart from the 1 gigabit version, 9200 also provide multi-gigabit modules. Of course, we will discuss the M-Gig in the coming slides. Okay, and talking about the stacking of 9200, the first thing about the 9200 stacking is 9200 and 9300, their stack cables are different. The pins on the stack adapter are different. So we can't stack 9200 and 9300 together. Okay. And we also cannot stack 9200 and 9200L together because the RAM capacity from these two series are different. Okay. Okay, the next topic is the multi-gig Ethernet. Coming to this topic, well, as you know, Wi-Fi 6 provide faster wireless speeds, but at the same time, the 1 gigabit infra becomes the bottleneck for better performance. So, like you know, for the old buildings with legacy cabling, both changing the cable infra or building the new cable infra are relatively complex and expensive. So with the multi-gigabit solution, the maximum speed over the Cat 5e cabling is 5 gigabit per second, and the 10 gigabits per second for the Cat 6 cabling. Generally, it's a very cost-effective and easy way to upgrade the network capacity. So we do have a bunch of the Cat 9K modules support this multi-gig ports. Yes, almost all Cat 9K series support multi-gig base. The only exception is the 9500. As a core switch, the 9500 is very rare to be connected to the access points, right? So the 9500 doesn't support it. And regarding the modular core switch 9600, actually there's only one 48 ports LAN card supports the multi-gig ports, but unfortunately this LAN card doesn't support PoE. So one more thing is about the multi-gig ports is on the 1U switches like the 9200, 9300 on the front panel, as you can see from the picture, on the front panel, all the multi-gig ports have the blue label under the ports. So if you go to the lab, want to find a switch that supports the multi-gig ports, so you can find the switch with that kind of the blue label under the ports. Okay. And here list, actually, I'm showing you some modules that have the multi-gigabit ports. Actually, the list is not up to date. We have actually we do have more switches have the multi-gig ports, but not in this list. Okay, so I think the slide is only for your reference when you want to find a switch with multi-gig ports to build your lab. Okay, you can take it as a reference. And the last thing about the multi-gigabit is by default, the multi-gigabit ports will auto negotiate the speed to the maximum speed the both end could support at the same time. However, if you want to set it to the specific speed for any purpose, we do have the command line for you with the speed keyword, as you can see here, with the speed keyword under the interface configuration mode, you can force the speed of the multi-gigabit port. Okay. Moving to next topic, that's the
Before you
stack-wise.
move to the next topic, please, I have a question regarding the multi-gig Ethernet slides. If you go back to that one.
Okay, sure. Is it this one?
No, to the switch comparing between the 1 gig and the multi-gig. The one before that.
This one?
So that one, yes. So this is based on 15 clients connected to 5 gigahertz, 3 clients connected to 2.4, because you have in the blue rectangle, you mentioned 15 clients connected to 5 gigahertz and 3 clients connected to 2.4. But in the dark blue, it's mentioned here 3 5 gigahertz, 3 2.4. So I'm not sure that based on what.
Actually, this is only the reference for you about the multi-gig ports. Actually, for the multi-gig ports, we can support up to 5 gigabit per second. So with the Wi-Fi 6, actually, it's only the data for the testing, and actually we can have the hair speed in any of the cases. So you can take it as a reference, and the only thing I want to mention here is actually about the capability of the multi-gigabit ports, and it can support up to 5 gigabit per second. And for the data, actually, we might need more information to explain the data here in these slides. We can talk about offline.
But the actual testing has been done with 15 clients or 3 clients?
Sorry, actually, I don't have the answer for you at this moment.
That's fine. Yeah, that's fine. I just I'm seeing that in the light blue mentioned 15 clients and dark blue mentioned 3 clients for 5 gigahertz. So I was wondering which one is the correct one. Okay.
Right.
No problem. Okay. Thank you.
Okay. Thank you. And moving on to next topic is actually the stack-wise virtual. Coming to the stack-wise virtual, it's actually a virtualization feature allows the clustering of 2 physical switches together into a single logical entity. So it's quite similar with the VSS feature on the Catalyst 6K. And in the Kite 9K, we rebrand the name from the VSS to Stackwise Virtual SV. Okay, the 2 switches operate as one. They share the same configuration and forwarding state. Comparing with the stacking, SV is actually in the core switching technology and is only supported on the 9400, 9500, and 9600. Because of the 2 switches operate as one, the spanning tree domain treats the SV pair as one bridge instead of 2. So it's simply the layer 2 design by creating a loop-free topology between the core and the access switches. also provide additional benefit like chassis level redundancy, and it can double the bandwidth with the MEC and simplify the management and so on. So we also want to talk about some key concepts in the SV. The first one is the SV domain. When you're not converting two standalone switches into a logical entity, the VS domain is created. So the SV domain actually refers to the logical entity consists of two switches. The SV link is actually in the special port channel running between two switches in the same domain. And the SV link actually carry SV control traffic as well as the normal traffic. Keeper live messages are also transmitted via the SV links. So the SV domain will break down if all SV links failed. Okay, and we also have the active and standby roles in the SV. All control plane functions are centrally managed by the active switch in the SV domain, and the other switch, the standby switch, will take the standby role and monitor the healthy of the active switch. It will take over the active role upon the failure of the active was detected. And of course, for the data plane perspective, both of the switches are actually in active status at the same time to forward traffic. They support local forwarding that pick up local links as the egress ports in the MEC. And if the destination is on the other switch, the traffic will be forwarded over the SV links. And the last thing about SV is actually please keep in your mind that not all modules in 94, 95, and the next 9600 support SV. There are quite many hardware and software requirements limitations. So as an example, actually, when I was a switching engineer, my experience is that you'd better to test it in your lab before suggesting any action about SV to your customer. Because of some of the limitations are not clearly documented at that time. So that's all about the stack-wise virtual. Okay, that's also the end of my first part. Let's pause here and see if any questions so far.
Yeah, hi Frank. Sumit this side.
Yeah.
Yeah, can you please explain the detailed step that how to configure Stackwise Virtual? I think there
Uh,
is a dual
okay.
active detection link is also there, no? Apart
Yeah.
from Stackwise Virtual link.
Actually, we have many guys to introduce how to set up the stack-wise virtual. Actually, we have a couple of the steps. Basically, we need to bring up two standalone switches. As you can see from this slide, we have two switches, two 9500, and we connect them from the specific ports and band them in the other channel. And after that, we need command the CLI to convert them from the standalone mode to the SV mode. That's the basic concept of the converting. And after that, you have the option to build up the DAD link as well. I'm not going to cover all the details about that in the slide because of the limit of time. So if you want to know more about that, actually, I provide some additional links at the end of my slides. You can refer to the detailed step of that.
Yeah, okay, no problem. Thank you so much.
Sure.
Yeah.
Okay. So let's move to the second half and let's review some basic switching concept together. The first topic is about the layer 2 learning and forwarding. And the first term is a MAC address. A MAC on a media access control address is an identifier that every network device uses to uniquely identify itself on the network. So no two devices anywhere in the world will have the same MAC address. And the MAC address is made up of the 6-bit hex number that is burned into every NIC by its manufacturer. As you can see here, the MAC address is broken up into two parts. The first 3 bits identify the manufacturer of the NIC, such as Cisco, Juniper, Huawei, Netgear, and so on. And the last 3 bits are unique number from the manufacturer that identify each device on the network. So the MAC address sometimes is also referred as a physical address or hardware address from different places. Moving to next, to make the accurate forwarding decisions, the switch learns and stores the MAC addresses of all connect devices. The switch stored the learned MAC addresses in a table that is known as a CAM table or MAC address table. The MAC address learning process is relatively simple. When processing an incoming frame, the switch checks the source MAC address of the frame in the CAM table. If the entry for the source MAC address is not available in the CAM table, it creates a new one for that source MAC address. If an entry is already available for that source MAC address, the switch only updates the existing entry. And this learning process happens along when every time the switch receives a single frame from its neighbor, regardless the type of the frame. That's about the layer 2 learning. And moving to the layer 2 forwarding, let's talk about it. When the frame comes to the switch interface, the first step, actually not in this picture, is that the switch learns the source MAC address of the frame in the way we discussed in last slide, and then the switch reads the destination MAC address of the frame and compare it with the MAC address table. Okay, if the destination MAC is known and listed in the database, in that condition, the frame is sent out through that interface only. But if the destination MAC address is unknown, the frame is flooded out of the active interfaces, only except the interface that receives the packet. Actually, the flooding behavior here is also known as the unknown unicast flooding. Actually, limited amount of the flooding is part of the normal switching process. However, continuous flooding can cause some problem of the network, such as packet loss. And one more thing about that is we need to take care is that the broadcast frames, they are flooded as expected. And regarding the multicast frames, they are also flooded unless IGMP snooping feature is enabled on the switch. That's about the forwarding, layer 2 forwarding. And we also have the command line to check the MAC address table. It's pretty simple. The only thing I want to highlight here is Cisco switches support the per VLAN MAC address table. So you might see the same MAC address was learned from different VLANs, right? And so you also have the option to check the MAC address table specific to the VLAN through the CLI. And if you want to clear the MAC address table specific to the VLAN, you can use the last CLI listed here. Another concept in the switching, especially for the multi-layer switch, is a switch port and a route port. By default, all switch interfaces on Kali switches are running in a layer 2 mode, which is also known as a switch port by default. And The only exception is the Cat6K. The Cat6K by default setting all the ports in the layer 3 mode. I mean the rotate port. So for any of the multi-layer switch we have, it is possible to switch the layer 2 port to the layer 3 mode by issuing the command no switch port under the interface. You can also assign IP address to that interface, the rotate port, and the interface is able to take part in any of the layer 3 protocol the switch itself supported. The rotate port is not associated with any VLAN, so it doesn't support any layer 2 communication like spanning tree. Another similar concept is SVI. SVI is similar to the rotate port in that it's the layer 3 interface that provide layer 3 packet processing. But don't misunderstand SVI and the rotate port. They are different. SVI is the virtual or logical interface which assigned to one VLAN, but rotate port is the physical interface. They are different. So basically, SVI is a logical interface that created by the users when needed. SVI can be created for each VLAN, but only one SVI can be mapped to each VLAN. And I believe most of you might have the experience that SVI keeps in protocol down status. Even the interface is already enabled by the no shutdown command. So there are mainly two reasons makes the SVI in the protocol down status. The first one is that the VLAN, the SVI map 2 is not created, which I mean you need to create the VLAN first and then create the SVI map to that VLAN. And the second reason, more likely there's no any active physical port in that VLAN, the SVI map 2, which means for the SVI, for the VLAN, the SVI map 2, you need to we need at least one active physical port mapped to that VLAN. So by checking these 2 points, that can help you to bring your SVI up. We also have some concept like the access and the trunk ports in switching. Access port can have only one VLAN configured on that interface. It can only carry traffic for only one VLAN. And a trunk port can have 2 or more VLANs configured on that interface. It can carry traffic for several VLAN at the same time. To deliver the traffic on the VLAN port with several VLANs, the device uses a IEEE.1Q tag to identify different VLANs. This tag carries information about the specific VLAN to which the frame or the packet belong. And actually, the trunk port can carry untagged packets along with the tagged packets. The concept of the native VLAN is a VLAN that carries untagged traffic on trunk port. It can be configured on the trunk port. By default, the native VLAN is VLAN 1, and all untagged traffic is assumed to belong to that VLAN. The native VLAN that configured on both ends of the trunk port should be the same. Cisco switches use CDP, Cisco Discovery Protocol, to detect the native VLAN ID configured by the other end switch, and it will generate an alert for any mismatch detected. As you can see from here, it's a sample of the error message detected by the CDP. And here are the examples for configuring an access or trunk port. For your reference, the only thing is a switch trunk allow VLAN command is used to specify the VLAN that load on the trunk port. When the layer 2 interface on the switch is configured to operate in the trunk mode, the default setting for the interface is to carry all of the VLAN defined on the switch. But if you want to specify the group of certain VLANs to be allowed on that interface, this command helps. another CLI about access and trunk. I think the most straightforward way to check the access and the trunk configuration of the switch port is that to do the show run interface command. You can easily find all relevant configuration from the output of this single command. And if you want to verify the switch port status rather than checking the configuration only, I think you can use the show interface switch port command. It is another good option. From its output, you will see the current operational module of the port. As you can see here, it's operating in the trunk mode. And of course, you can see it is the switch port on the routing port. Here in this sample, it's in the switch port. And if we put the no switch port command under this interface, the switch port status will be disabled. Okay, and of course, apart from that, we have the output of that the forwarding VLAN list for the trunk port, and the native VLAN of the trunk port is the VLAN 1, which is by default. Show VLAN brief is usually used to check all VLAN configured on the switch, and you can also use this command to check the mappings between VLAN and the access ports. Okay, and regarding the trunk ports, show interface trunk can help you understand how many trunk ports you configure on the switch. In this sample of VRSday, I have only one trunk port, J1/1, and looking at the VLAN list I marked in orange, let me explain a bit about them. Okay, the first one on the top, which is named as the VLAN allowed on trunk, consists of the allowed VLAN ID I configure under the port with the command switch port trunk allow VLAN. And the VLAN ID in this list are exactly what I configured. And moving to the next one, the second one, list will tell you that the VLANs you configured and currently in the active status. One of the reasons some of the VLAN are inactive in this list, that because we are not configure the VLANs on the switch properly. In this example, even I allow trunk port to forward VLAN 20, but however, VLAN 20 is not actually configured on the switch. So I'll need to add VLAN 20 to the database first. Okay, and the last one at the bottom, which I think is the most important list, showing you the VLAN list that are actively forwarding traffic on the given trunk port. There's two reasons that make the VLAN not listed in the last actual forwarding list. The first one is that spanning tree might block this port. That's the first reason. And another one is that the VLAN is pruned by the VTP. So VTP reason might be overlooked because we don't usually use VTP and we don't have any other command shows the information about VTP pruning. So the suggestion is every time you are dealing with the forwarding issue on a trunk port, you might want to use this command and make sure your desired VLAN ID is in the bottom list. Okay. Moving forward, another CLI, which is also one of my favorite, is that is the show VLAN ID. It shows you all access and trunk ports that are configured to forward traffic specific to the VLAN. Without this command, actually you might need to use show VLAN brief plus show interface trunk to find them all. So this command would be helpful when you want to find them all in one shot. In this example, take it as an example, I use a CLI show VLAN ID 1. So all of the information is about the VLAN 1. And we can see a couple of the ports listed here. In these ports, some of them are access ports, and some of them actually are trunk ports and forward the VLAN 1 at this time. Okay, that's about the CLI. And moving to next is a topic of spanning tree, as you know. It is one of the most important technology in the layer 2 network. And with that spanning tree, it can remove layer 2 loops by blocking the redundant links. The redundant links means an additional link between two switches. As you can see from the picture, there are two paths between switch A to the root switch. The biggest advantage of the redundant link is that it actually creates a loop between switches. If a loop exists between two switches, they do not work properly. So after a series of calculations, spanning tree decided to block one of the uplinks of switch A to make the network stable. That's the basic idea of the spanning tree. And talking about the spanning tree implement on Cisco devices compared to the standard spanning tree, which is defined in 802.1d. Cisco switches implement the per VLAN spanning tree on a rapid PVST. PVST is the Cisco enhancement of the standard STP that provides separate spanning tree instances for each VLAN we configured in the network. So for example, if you configure 20 VLANs on a switch, with PVST, the switch will create and maintains 20 spanning tree instances at the same time. Portfast. We have a lot of features on the spanning tree. Here I only list some of them. The first one is Portfast. Portfast can make the switch port enter the spanning tree forwarding state immediately by passing the listening and the listening states. Typically, spanning tree costs more than 30 seconds on the listening and the learning states before moving this interface state to forwarding. So if the switch port is connected to the single workstation or any device that don't take part in the spanning tree calculation, the best practice would be enabling Portfast on that port, no matter it's the access port or the trunk port. And another benefit from the Portfast configuration is that the topology change notification, which is also referred to the TCN. The TCN are generated when there's a topology change, including enabling or disabling the port. The series of action happens on the switch upon receive of the TCN. One of the action is to flush the MAC address table in that given VLAN, assuming the switch have thousands of MAC address learned from that VLAN. That will bring a significant load to its CPU to restudy those MAC addresses. So by enabling Portfast, they do not generate TCN anymore when every time the host come online or offline. Okay. The second one is BPDU guard. Assuming that the Portfast is enabled on the port connect to another switch, yes, another switch, which is running assuming the switch is running a spanning tree. In that scenario, that will cause a spanning tree loop. So BPDU guard is a feature make sure the ports that with Portfast enabled will not take part in the spanning tree calculation. So with the enabling of the BPDU guard, if BPDU is received from the Portfast enabled port, spanning tree will shut down that port immediately to protect the spanning tree domain. Okay. The third one, root guard. Actually in a well-designed layer 2 network, it is very important to identify the correct placement of the root bridge. So the root guard feature prevents the configured port from becoming the root port, which means it could prevent the downstream switch becoming the root bridge. If the superior BPDO is received on the unexpected port, the root guard feature will place that port in the error disabled status. Okay, that's about the root guard. So as I mentioned, there are a couple of features about the spanning tree. You may refer to this link and find more about that. So I'll move to the example of the spanning tree configuration. The first one is about the 3 mode of the spanning tree we support on Cisco switch, the MST, PVST, and the rapid PVST. You can select one of them. And here also are the examples of the interface command to enable the pull fast. This is the pull fast, the BPDU guard, and the root guard. Another CLI about spanning tree. Come to the verification of spanning tree. You may see the spanning tree is running on a per VLAN basis. From this sample, you can see this. Of course, I use this command with the VLAN 1 keyword, but if you do the command show spanning tree, you might find a lot of instance for each VLAN we have on the switch. And this switch is actually running on a rapid PVST, and you may find the addresses of the root bridge and the switch itself. Obviously, this bridge is not a root bridge, and all interfaces in this given VLAN are listed at the bottom, and you can easily find that currently one port is in the forwarding state and another port is in the block state. Okay, and moving on to next is either channel. Either
So
channel
before
is
we move forward with the slides, I have a question regarding the spanning tree. So
okay.
One issue I remember with 2 WLCs in HA connecting to 2 Nexus 9300-EX series, the switches were connected using BTP. We had so much trouble with those WLCs connected to the switches until we put under the port channel configuration the command spanning tree, port type, edge trunk, and everything started working without problem after that. So this command was added by the switching tech engineer. Can you let us know what this command is actually doing with spanning tree? The command is spanning tree, port type, edge trunk.
So you mean you do this from you put this from the Nexus side, right? Actually,
That's correct. Yes.
actually this kind of the port fast setting on the switch actually as I mentioned earlier, for the interface, if you connect it to the workstation on any device that doesn't take part of in the spanning tree calculation, we would suggest you to put that interface in port fast status, no matter it's the access port or the trunk port. So basically, the configuration command line from Nexus and Catalyst is different. But what I heard from you that the command from Nexus side is to configure that trunk port in the port fast status, which doesn't take part in the spanning tree calculation. But about the root cause of your issue, why it doesn't work with all this configuration, I think we might need to take a look of your case and to deep more about your case.
Okay, so the spanning tree, port type, edge trunk, that means it's equal to the port path what we have in the iOS XE command.
Sure. Yeah. Yes. Correct.
Okay. Thank you.
Yeah. Basically, we have different CLI from different platforms. Okay, the next topic is either channel, which is also known as port channel or lag. It allows to group multiple physical links to create one logical link. So you can assign up to 16 physical interfaces to an Ether channel, but only 8 interfaces will be active at that time. Using an Ether channel actually have a lot of advantages, assuming you combine 2 links into one logical Ether channel, then it will double your link bandwidth, obviously, and you don't need to worry about the spandry block because the Ether channel actually acts as one interface. Traffic load will be balanced across the links and provide redundancy in case one of the link goes down. PGP and LACP are the negotiation protocols that dynamically configure an Ether channel. PGP is a Cisco proprietary protocol, so you can only use it between Cisco devices. LACP is an IEEE standard, which almost all vendors support it. So of these 3 available method lists here, actually this is the LACP is a preferred one to use. It's also possible to configure a static Ether channel without this protocol doing the negotiation for you. So LACP will be supported on all Cisco switches, but maybe you are connecting to another vendor switch or server. Using the static way to configure the Ether channel is not the recommended way. However, we will use static if LACP is not supported on both ends of the devices. And the only tips about creating an Ether channel, you'd better clear the configuration of each member port, or at least make sure the configuration of each physical port are the same before grouping them into the Ether channel. Otherwise, while creating the Ether channel, you may see mismatch that prevent some ports from joining the Ether channel. And to configure an Ether channel on Catalyst, the first step you may use the interface range command. That allows you to configure multiple interfaces at once. Then you can group them to the Ether channel. In this example, the port channel number is number 1, and there are multiple modes that you can select. Active and passive keywords are used to enable LACP as a negotiation protocol. And if you use LACP, at least one switch should be configured as active mode. Otherwise, the Ether channel won't bring up properly. So if you want to use the Cisco PGP as a protocol, the desirable mode is very much like the active mode in LACP, and the auto mode has the same usage as passive mode in LACP. And the last one is mode on, which stands for configuring a static Ether channel without any negotiation protocol. So once we selected the mode, the port channel interface will be created automatically. You can also find it from the CLI like show interfaces. You can see the interface port channel 1, right? And the last one about the verification of the Ether channel. When you want to verify or troubleshoot the Ether channel from the Catalyst switch, show Ether channel summary should be the first command you look into. As you can see from the output, it shows an Ether channel in the healthy status. You may look to the code following the port channel ID. SU here, S stands for the layer 2, and U stands for in use, actually in the up status. And the code following the physical port ID is P. P is also in the good status. Assuming you find any other code in your Ether channel in your environment, you may refer to the flag instruction within the output and to start the troubleshooting the problem by getting understand what does this code or flag stand for. You may use Google search or topic search, and I'm pretty sure you can find a lot of things to explain the code listed here for your troubleshooting. Okay, resources, the last thing. We are coming to the last slide. I didn't put too many links in this slide because I know Each of you can easily find useful information about switching and K9K from the internet. So what I listed here are actually my recommendations for deep dives. If you are interested on any of the Kelly switch I mentioned today, or you want to explore more details about the features about Kelly switching, the, the switching.cisco.com is the best website for you to start your deep dive. And the second one is the CCNA course on the CDLL, the Cisco Digital Learning Library. Basically, it's a very well structured training. It's very comprehensive and consists of a lot of knowledge about networking, routing, and switching. So if you are a new person to the network, I highly recommend you to go through this free e-learning course. And the second last one, you may be very familiar with this, the software configuration guide of the CAD 9300. By reading the configuration guide, you may know which features are supported on the latest software and how Cisco Switch implement the features. And you might also see some restrictions or tips for configuring the switch. And another reason I suggest the guide of 9300 is that compared to other mode we have in K9K, the 9300 is actually very easy to find in your lab. And the last one is about design. By reading this, you could probably understand more about the design concepts and the considerations in a wired and a wireless LAN. Well, that's actually all contents I prepared for today. Again, thanks so much for your joining and listening. Looks like we don't have much time for Q&A, so I will take the Q&A part offline. Please feel free to contact me if you have any question about switching or switches. All right, that's it for today. Have a good day, good week ahead. Bye.